First things first, put your gloves on. You don't want to touch this, it stinks. Gear oil has a very particular pungent odor that smells like dead fish and garbage. So some people may be asking, what are we doing here? Well, as you see, I've got the differential carrier out, and the differential carrier, for all intents and purposes, looks okay. That's what's there. But right now, I'm in the process of pulling the diff lock actuator so I can pull the sleeve out because something is chewed up and ground up. And on this really cool 90-degree day in the shop where it's got a light breeze from my cameraman's breath as he breathes on me, I got sweat dripping out of my gloves. We're going to pull this so we can find the final bit of carnage up front here. Four bolts hold it on. It's a pneumatic actuator. And in my infinite genius, the way I racked this on this drive-on rack, I can't pull the track bar all the way off because the mounts are in the way. So I'm going to have to find a way to support this truck to yank this whole front axle, because through, I think, no less than 37 phone calls back and forth, we've surmised that we're going to go ahead and put 1-ton axles underneath this thing. Oops, gross. More fluid's coming out. So the actuator's pretty simple. We'll just set it aside. And let me come out over here. With that out, we should, there we go. Look at this. Chunks fell out. Well, hot damn, there's a problem. Teeth are all chewed up. That'll do it. That's why we did not have front wheel drive either, because this let loose and it slid off of itself. So this has to be replaced if we were to keep these axles. The other thing is, man, look at the wear on this. That's supposed to be a floating device, so it was rubbing on something. So the way this works, this thing engages with that when the lockers are engaged. And when this is under full force, and now that we've got an angle on this, when it's under pressure, it's going to unlock itself no matter how much pressure's on it, and it's going to slip. That sucks. So if we were to keep these axles, not only are we looking at major surgery for the rear axle, which I have an update on that, now we're also looking at a shift collar, we'll call it that. And we'll try to clean this up, but realistically, we're probably looking at a carrier up front too. So 2 carriers, and a rear axle shaft. So internally, this carrier seems okay. Everything still moves and rotates. It's just heavily contaminated with metal. But since y'all are here, we're going to show you what a good axle looks like versus one that's got a boot torn. So come on over here. Okay, so for those of you that wonder, like, what is Joe talking about when he says your truck needs a front axle rebuild? What I'm talking about is the seals inside of here, the CV boots here get replaced. Sometimes we even replace the whole outer CV shaft assembly. And then inside of here, which is your swivel ball, this goes on the end here, you've got seals, you've got wheel bearings, and seals. Believe it or not, this one is actually in pretty good shape. Still has the factory Mercedes butterscotch looking grease. Looks like peanut butter, whatever you want to call it. This one we can really just put it back together, some new gaskets, and call it a day. Pretty good shape. So long as, you know, it still has that butterscotch ring. Looks like someone just shoved a toilet gasket in there. Hell, anyway. But for lack of, just so you guys have a visual, this slides inside of here and rotates like so. Now, what happens over time, and this is what prompts us to do the front axle rebuild, is there's grease inside of here. This one's still intact. It's good shape. It's still squishy. There's no rips, no tears, and we don't have anything coming out of it. I can see. But if I flip this up a little bit, you see we've got like this black green goo here. What happens is when this boot tears, this green goopy stuff flies out and fills up the inside of this. it's a bit more viscous and liquidy, i.e. gross, and it contaminates it, and it starts spooging out of the scupper seals and makes a whole new mess. Let's look at one that's bad. So over here on the passenger side, now granted I've already cleaned it up because it was really disgusting. I basically just pulled the trash can over here, scooped out all the stuff and called it a day. But you can see the remnants. This one, how it's not butterscotchy, it's kind of that gross black-green stuff. Yeah, it looks like this. You know, it looks like your goth girlfriend's eyeliner. Yuck. But what happens is this. Over time it wears out, and the swivel bowl, or I'm sorry, the CV axle boot tears open and all the grease flies out. And then the lubrication is supposed to keep this nice and slick, flies out, and then slowly it just doesn't have any more in it. Grinds itself to a loose, powdery ball of dust. Gets expensive. So, hindsight is this truck has, give or take, 60,000 miles on it. One side definitely needs a rebuild. We usually catch this when we see the discolored grease coming out the scupper bowl. So, there we go. Now that we have that out of the front axle, it's basically a bare axle minus the pinion is still in it. We can see that we need to order some more pieces and parts to put this back together. However, through all events transpiring, we're actually going to unbolt these axles from the chassis itself, and we're going to take them down to a local race car fab shop and have Dana 60s fabricated to put underneath this. And that's going to be a whole nother ball of wax we're going to tackle, mainly because A, chromoly axle shafts don't exist in the US for this truck. There's some overseas, but they want arm and a leg and all your toes. It's ridiculous how expensive they are. So rather than going down the road and just having axle shafts made, only to find the next weakest link inside the axle, we're going to step up to a full 1-ton, full floating Dana 60 style front and rear with hub fuses so we can avoid this in the future. We're going to widen the track and make sure we get the gearing appropriate to run not only 35s, we're going to step it up to run 37s on it without braking. It's going to be pretty cool. We're still going to keep the radius arm suspension. We will modify the angles a little bit for the pinion and the kingpin so we can get the caster dialed in and the pinion angles set so we can minimize all driveline vibrations and basically have it behave a little better. With 35s, it's really freaking good, but we're always chasing that 1%. So that's part of the equation of what we're doing now. So stay tuned. That's going to be a whole nother process, lots of engineering. I will say it presents a little bit of a challenge being as we have wheel speed tone wheels at each wheel. These are 48 tooth and speed sensors, and we're going to have to correlate that with the new axles to make sure we have the same tooth count. And we're going to have to make sure we have the right gearing in there that the ABS module will recognize so it doesn't freak everything out. Because believe it or not, we need that and the gearing to be correct for the transmission to shift correctly. So there's some trickery that's going to go on behind the scenes to make everything walk and talk and communicate right. But I've got a couple other trucks to play with here, so we've been programming different things in there. And so far, I'm pretty happy with knowing that it will work. So stay tuned on that. We're going to clean up all this mess. At the end of the day, we still will have a spare set of G-Wagen axles at our disposal, but ugh. Okay, so we're going to update on the rear axle. We're going to put the truck up in the air a little bit, and I'll explain what's going to happen there. It's going to be fun. Okay, now the intermission's over. Here's what we're going to do. We have tried everything. We had an arc welder, a MIG welder, everything. We even took welding rods in and tried to weld to the shaft to pull it out. It didn't happen. We cranked everything up to 240 volts, or I'm sorry, 240 amps. Tried to max everything out. Not gonna happen. So what we're gonna do instead, because no, we can't push anything through this side. We've already tried that with little rods and things, but the carrier is closed, so it means we really can't get through it. Here, come around the back side. We are gonna use what we call I'm done asking tool. We're gonna pull these caps. This will come loose a little bit, and then we're going to fire up our oxyacetylene torch, the redneck's favorite tool. We are going to cut it right through there because the axle shaft is stuck in the middle. Once we cut this and unbolt this, we'll be able to pull the carrier out, pull whatever we have in there out this way. It'll remain in that little collar thing. And then we start over on this. So fortunately, we can still get the carriers. Are relatively inexpensive in the grand scheme of everything. It's just one of those like, ugh, come on, are you kidding me? We're so close. Anyway, yes, we've exhausted all efforts. We've welded it, we've tried pushing it, we tried closing it up, we tried pressurizing it, we tried freezing it, we tried everything. We're over it. So that's gonna be fun. We may record it as it happens, but I'm sure no one likes to see someone take a torch to a rear axle. So another reason why we're gonna upgrade this to a Dana 60. So in the future, if we do have any breakage, it's not gonna be an issue. We can just trailside repair it. So cool stuff. So you've maybe heard me talk about upgrading this to what we call a Dana 60. For those of you that don't know what that is a really heavy-duty axle that came on all the one-ton Ford, Chevys, and Dodges back in the day, and it's still used widely today in the off-road world for built Jeeps, Toyotas, trucks, you name it, because they're big, beefy, and they just don't break. So what does that mean for this? It means the components are physically larger. For starters, the axle housing is going to be larger. The tubes on this are about just under 3 inches. When we jump up to a Dana 60, the axle diameter housing itself is going to jump up to minimum a 3.5-inch tube. We can even opt to go up to a 4-inch. We can go nodular iron. We can even go chromoly. The other thing that's critical, though, is the carrier that actually transfers the torque or engine load or power, however you want to call it, the forward momentum, goes from this little, oh God, it's small. It's like 8 or 9 inches. It's 8 and some odd quarter inches here. It jumps up to about 11-inch carrier. And when you jump up to a physically larger carrier like that, you're about 25–30% larger, you've got a pretty substantial increased surface area where you can introduce more torque, more horsepower, and bigger components. And what does that mean for us? That means that we can put more torque, more horsepower, more shock load before we break anything. So with that, the axle shafts that go inside of a Dana 60 are also going to be a lot larger. These are pretty small. This is only about 1 inch in diameter to 26 spline units. It's pretty small. This is like half-ton pickup truck style. Even Jeeps use similar stuff. It's not really big. It is stout for what it is because Mercedes does a great job of managing torque and all that stuff effectively, but this can be made better. So by going up to a Dana 60, we have the option of jumping up to like a 35 or even a 40 spline unit, but we can go up to 1.5 inch or 1.75 inch shaft. The thing is that it's substantially larger. There's a lot more surface area and material to work with. Again, we're shooting for about a 30 to 40% increase in overall torsional strength. And by going to a chromoly shaft versus a hardened steel, it gets us a little bit more flexibility. Without geeking out too much and going into a whole bunch of math that you guys probably don't want to see, hardened steel is really good. It has a high tensile strength and it's really strong. The downside of this is it's brittle, meaning that extreme shock loads will cause it to not twist, but it will crack and shatter and break, hence what happened on the rear. By jumping to a chromoly, it offers a little bit more flexibility and it's going to be a little bit more malleable. And by doing chromoly axle shafts on the rear and the front that are not tapered, they're straight, it means that when we do encounter a shock load, it's going to twist a certain amount of degrees and then spring back, which takes that shock load and distributes across a wider range and won't break. That's the reason for it. It's not all about being as hard and strong as we can. It's about being able to withstand the force effectively and bounce back. That's the name of the game. So we're going to upsize the ring and pinion. We're going to change the gearing ratio, larger axle shafts, larger housing, and also by going with that, your kingpins and your bushings up, your kingpins and ball joints up here are going to be much larger. And then it opens the possibility for all kinds of brakes. So we're looking at not just AMG brakes, but really we'll probably put a set of Willwood brakes meant for like a 1-ton pickup truck on there. And they're massive 6-piston calipers and they're meant to work with 18-inch wheels. And that's going to be a game changer. We're going to see if we can do a nose wheelie once we have one of those on. I've run them on our shop truck and been pretty thrilled with them. So lots of cool options here. I think that's going to be the best bang for the buck for this truck, largely because if we do portals, we still run the risk of a small carrier. We still have the shock load issue, and we still have factory axle shafts unless we're going to have custom chromoly ones made for the factory G-Wagon. So I think what I'll do is I will post something later in another video where I kind of write everything out for the math geeks out there. We can talk about why we chose this route and the mathematics behind it and why it makes sense. And then I'll also go into a little bit of how we did this and got all the systems to stay online. We're not going to lose ABS. We're not going to lose traction control. We're still going to be able to shift. We're going to be able to work correctly. And the key thing is it's going to be reliable going down the road. So that's the name of the game.